have studied about the vectors and the matrices, and now beginning with the matrices, we have been doing the various operations that can be done using the matrices. And we have seen that your matrices, they are help us in solving the linear equations. So we are moving towards the providing the solutions for the linear equations using the matrices. So what is a linear equation basically? When we have, like, if we consider a scenario like one of you goes for shopping and buys 3 kg apples and 4 kg mangoes, and and you paid let's say 500 rupees, and another next time you go for shopping and you again buy 2 kg apples and 4 kg mangoes, and you pay 300 rupees. Then what is the cost of apples and what is the cost of mangoes per kg? Then how are you going to represent that? We represent such kind of problems using the linear equations. Or here you can say in this particular example, 3x plus 4y is equal to 5. Let us say x is apples and y is mangoes. Similarly, so formulating these equations, now we have to find out the solution to these equations. See, in your you can say in your 12th class, you have studied about the linear equations, and from there you know that it is easy to solve the linear. See, we have different methods to solve the linear equations. Like the first one, you say you can solve the linear equations using the graphical methods. But when we have just two variables, let's say we have just x and y, two variables, it is easy to solve these equations using the graphical methods, because you can simply plot these two equations in the graph, and then you can find the point of intersection, and from the point of intersection you can find out the coordinates for x and y, and these coordinates represent the values of x and y, that is the values of you can say the mango that we are trying to compute, the apples per kg, the price of apples per kg, or the price of mangoes per kg. So but when we say the number of variables start increasing, so if I tell you that you have another variable z now in this equation, how are you going to solve it? Yes. So can you solve the equation with 3 or 4 variables using the graphical methods? Any of you?
No, ma'am.
So what we will do?
Using
Mistake
matrices or
method.
So that means we
using the
have, yeah,
matrices.
so by substitution, by elimination, right? So that means when we have more than two variables, the finding a solution to the linear equations become complex. So that means if we have more than 3 variables or 4 variables, that means if, let us say if we have 10 variables, that means with the increase in number of variables, the complexity of the solutions, you can say the complexity of the problem starts increasing, and with the increase in the complexity, the basic solutions, the basic methods, they are they're not suitable for providing the solutions. So what do? We find out the alternative methods which are suitable for finding the solutions to the linear equations which are having a large number of variables. So here we have said, you can see we have represented this equation in the form of a matrix. Now, when we talk about the linear equations, what are the possible number of solutions that we have in the linear equations? We say when the m is equal to n, where m is the number of equations and n is the number of variables. If the number of equations is equal to the number of variables, then we have a unique solution. That means you will find one solution. Now, if the number of equations is greater than equal to number of variables, then there is no solution. No solution exists. And if the number of equations is less than the number of variables, that means we have multiple solutions. We may have more than one solution. So we say the system has a unique single solution, it has infinitely many solutions, or it has no solution. So once you have any set of linear equations, so these are the possible answers, you can say. So we have three possible answers. One is these two equations can have a single unique solution, or it can have multiple solutions, or it can have no solutions. So how do we find out whether this set of equations will have which particular answer is suitable for this set of equations? So what do? We try to solve the set of linear equations with for more than two variables. Let us say the first example that we take up is the number of equations, linear equations with 3 variables. Let us say you purchased apples, mangoes, and bananas. So that means we have to find out the price of mangoes, apples, and bananas, each represented using X, Y, and Z. Right? So when we, the first step, see, when we have to solve the linear equations using the matrices, the first step is to represent the linear system of equations using the augmented matrix form. We learned about how to represent the equations using the in the form of augmented matrices in the last class. So here you can say, when we have these three equations, so what the first matrix we have taken is, that is the coefficient of each variable. So coefficient, let's see the first equation. First row represents the coefficients of the first equation, second row represents the coefficients of the second equation, and third row represents the coefficients of the third equation. So here you have 3 minus 2 1. So we have we have written the values which are there on the right hand side, separated by a, you can say, by a straight line, so that we can establish that these are the values of the matrix, and these are the final values that we are looking for when we satisfy, when our variables will be satisfying these equations. After representing these linear equations in the augmented matrix, we reduce this matrix into raw echelon form by applying the elementary row operations. So there are basically three row operations, which are, one is you can do interchange the two rows, or you can multiply one of the rows by a non-zero constant, or you can add a multiple of one row to another row. So after that, in the third step, what do? We use the Gaussian elimination method to over the row echelon matrix, so that we are able to find the values of these three variables, that is X, Y, and Z. So let us, I will represent this. See, Ri plus alpha into Rj is equal to Ri. That means we are, see, these are the symbols we will be using. See, first of all, we know about the augmented matrix form, but we have to understand the row echelon form. So for understanding the row echelon form of this matrix, how to convert a particular matrix into its row echelon form, we just try to understand these symbols we will be using, because we are doing this by applying certain operations over the rows. So R represent rows, I is the row number, then R is equal to, we can say Ri is equal to Ri plus alpha into Rj. That means alpha is some scalar value, scalar constant. We are multiplying row j, it can be any of the other two rows. So multiplying this complete row and then adding to one, we are, updating that particular row. Then it can be any of these things, no? So or what we can do, we are not adding that to the previous row, we are just multiplying it with a scalar constant, or we are just swapping the row 1 with 2 or 1 with 3, so that we are able to convert it into row echelon form. Now we have to understand what is row echelon form. See, a matrix, we say it is in the row echelon form when it satisfies any of the following three conditions. So the first non-zero element in each row. So see the element number 1 1. Okay, row 1, column 1. So this is called as this should be the leading entry, that is 1. So here you can say, in A, B, and C, these three matrices, the first entry is 1 in each. So that means cell number 1 1, row 1, column 1. Then each leading entry is in a column to the right of the leading entry in the previous row. So that means moving from first row to the second row, so the next entry, the leading entry 1, should be not in the same column, it should be in any column next to that. So let's say the 1 was in the first column, so that in the second row, it should be in the second or third column. It will not be there in the first column. Then we say the rows with all zero elements. So that means if you have any row with all the zero elements, it should be below the rows with the non-zero elements. That means in the example B, you see the last row has all the zero elements. So this has to be below the rows which have non-zero elements. All the three rows here we see they all have non-zero elements. Only the fourth row has zero elements. So it has to be below the non-zero elements. Similarly, in the C, you see the row with the zero elements lies below the rows with the non-zero elements. So all these three matrices, we say these are in the row echelon form. So that means you can understand, see, if we have any matrices, any matrix that we have formed from the set of linear equations, so in that case we have to convert that particular row into this any of these kind of forms. So that means the lower triangular, a little you can a bit of it looks like a row diagonal, no, not the diagonal, but a lower diagonal matrix where we have the zeros in the lower part. So along with that, we have to see the leading element is 1. So this leading element is basically called as the pivot element over here. So now what we have to do, see, we have to perform the operations in such a way that these elements in the row, that means you can say the elements below corresponding to row 1, the elements below which are there in the row column 1, but row 2 and 3, they should be 0, and others should be either we should have the pivot element, and then these three conditions must be satisfied. So now we are going to see, we are going to take the example so for solving this particular problem. So what do we do when we use the Gaussian elimination method? So in that case, first of all, from the given set of equations, we compute the augmented matrix. After computing the augmented matrix, we convert this matrix into the row echelon form. Now for converting this into the row echelon form, let us see the operations that we are following. So see, in the second step, we are multiplying. See, in the row 1, so we have 4, 8, minus 4, 4, 3, 8. Now we want the first leading element, that is cell 1, 1. This entry has to be 1 so that we can convert it to row echelon form. So for making it 1, what do? We multiply this row 1 with 1 by 4. So division of 1 by 4 will give us 1. So we are able to find the new matrix, that is 1, 2, minus 1. So we are writing it row 1. That means we are following this operation only on row 1, not on the complete matrix. So after applying this row operation R1, then we are able to get this new matrix. So that, and see, we are applying the not only the matrix but also on the values which are on the right hand side of these linear equations. So even 4 is divided by 4, so we get 1. Now what do we do? See, we have to understand what kind of operation should be performed so that we are able to make the values in this particular, all the values in this particular column equal to 0. So what we are doing is, here we are doing two operations. First on the row 2, so R2 minus 3R1. Now in the first 3R1 means, so because in the second row we have 3, 8, 5, and we want to make 3 to be 0, we can do that only by multiplying the row 1 by 3 and then subtracting it. So the same process is being followed, R2 minus 3R1. So R2 minus 3R1, so this is R2, and we multiplied the row 1 by 3, so we get 3, 6, minus 3, and 3. So when we subtract that, so we get 0, 2, 8, and minus 14. Similarly, for making the, you can say the cell value, this is 3, 1, 2 is 0. What do? We do R3 is equal to R3 plus 2R1. So because minus 2 is already, it is a negative sign. So when we will multiply the row 1 by 2 and then add to it, then it will become 2 minus 2 equal to 0. And all other values to be retained as it is, because in the row echelon form, we have to focus on this particular part, the lower triangular part. So in that case, so when we are able to get this, now we have to see further how to convert the other columns so that we are able to get the complete row echelon matrix. So in this next step, what do? We multiply row 2 by half, so that the second, you can say this is 2, 2 value, that is the cell value of second row and second column, we are able to convert it to 1. So when we for that, we have just multiplied the row 2 by 1 by 2, and we get 0, 1, 4, and minus 7. Now the third next step that is required is to convert the third row value under the pivot, that the value under this 1, it should be 0. So this is important. So what do? We do R3 is equal to R3 minus 5R2. So what we are doing, we are multiplying the row 2 by 5. So and then we just subtract it, and so we are able to get 0. And finally, this matrix, we say this is in the row echelon form. And then after that, we have to sorry, the third step, that is last step that is required, is because in the third row also we have to find create 1. So what do? We multiply that by minus r by 10. So we, because if we do multiply it by 1 by 10, it will be minus 1. So we are looking for the positive values. So we multiply it by minus 10, so we are able to get the unit value, and this value is equal to minus 2. So now we are able to convert the original matrix created from the set of linear equations into row echelon form. And now what do? See, from here, when we see the matrix, so from here we can see it is very easy to find out the equations. If we formulate this and convert this into the equations, we get z is equal to minus 2, y plus 4z is equal to minus 7, x plus 2y minus z is equal to 1. So we already know the value of z is equal to 2. So we can put this value over here in the second equation. So we get minus 8, and minus 8 plus 7 is equal to 1. So we get value of y is equal to 1. And when we put this value of z and y in the third equation, we are able to get the final solution, that is minus 3, 1 and minus 2. Now, in any of the steps that we have taken, if you are not able to understand any step, let me know, and then we will start with the exercise part. Anyone who is not able to understand any of these steps? Am I audible?
Yes.
Any steps? Anything not clear?
मैम एक बार
Yes.
मैम एक बार प्रॉपर्टी बताइए मैम.
Properties.
रो echelon. Yes मैम.
Okay, so see what we are seeing is, see the first non-zero element in each row. This is called the leading entry is 1. That means it is mandatory that the leading entry will be 1, right? So in that case, the leading entry in the first row is 1. Here the leading entry means after all the zeros, right? The first entry that will be there in the any row will be 1, and then in the third row also it will be 1, right? So this is the first property that we say. Each leading entry is in a column to the right of the leading entry in the previous row. So that means in the previous, see, let's say this is row 1, and we want to find out the leading entry in row 2. So this leading entry, the leading entry in the second row will be in the column next to the, so जैसे कि मतलब you see leading entry in the first row is in the first column. So for the leading entry in the second row can be in the second, third or fourth column. It can't be in the column number 1. Similarly, if we have the leading entry in column row 2, it is in column 2, then the row 3 cannot have a leading entry in column 1 or 2. It can only have leading entry in column 3 or 4. That means after that. Clear? And the row with all the zeros, that means like this in the B. See, the last row is 0. So this row with 0, it cannot be in, you can say row 1, 2 or 3. That means the row with all the zeros, it will be always the last row, or it will be lie below the rows with which are having the non-zero elements. Clear? Yes? Okay. So linear equation, we have discussed that it may have any one of these solutions. Case 1, it has one solution. If each variable in the row echelon form is a leading variable, the system has exactly one solution. Then find the solution by using simply the back substitution or other methods. So here we see, if we have a row echelon form in this form, each variable is a leading variable. Then no solution if the row echelon form contains row that represents the equation 0 is equal to C. If we have three variables A, B, C, here you can see in this equation we have three variables. Let's say it may be X, Y, Z or A, B, C. See, where C is not 0, the system has no solution. Here we have C0, but it's corresponding to this, its value is equal to 1. So these are the contradictory statements. You can say this is the contradictory situation. So the equations are inconsistent. So we say it has no solution. Then if the variable in the row echelon form are not all leading variables, right? And if the system is not inconsistent, it has infinitely many solutions. So here we can see, here we have the Z is not a leading variable. It should have been 1. If it has been 1, it has one solution. If it is not 1, and this value is also 0, then it can have infinitely many solutions, and the system is called as dependent. So from the, you can say that just by looking at the, you can say the row echelon matrix itself, you can tell whether the matrix will have the, whether the set of linear equations will have one solution or no solution or infinitely many solutions without further going for finding the solutions. That means you need to, in the second, like in the Gaussian elimination method, in this particular technique, after converting the matrix into row echelon form itself, you can find out whether the solution, you will have the one solution, no solution, or infinitely many solutions, rather than just going for finding the solution in the third step. If it has solution, you can directly see. So you have a reasoning for that, that the 0 is equal to C, you represent the equation 0 is equal to C, that means here Z is equal to 0, but where the actual value is not equal to 0, so this is a contradiction, so it will have no solution. So from these three examples, you can understand from the row echelon matrix itself, you can give a decision, or you can conclude whether the linear equations will have one solution, no solution, or infinitely many solutions. Now you take out your notebooks and start working.